Okay, so the first thing we're going to look at is the cloud migration assessment and the discovery of the on-premises resources. And to get to this area, when we log into the portal, we're going to click on the Analytics button in the top menu bar, and then go over to this Cloud Migration Assessment option in the far left. So we'll see over on the right-hand side, there are two options that we have. One for importing data that we've done from discovery of the on-premises environment, and then also the creation, right? So we can actually connect this directly back over to our on-premises environment if the networking allows for it. So we look at this drop-down button over here, we can go through and add in a brand new provider, and then I can go through and add in a new vSphere provider, populate this with all my access information, and do a direct connection back over to pull in all the on-premises details. Now, if we don't have the network access configured for that, we can also import the data by running a tool that we provide, locally in the on-premises environment itself. So if you go ahead and you download this tool by clicking the Download Here button, you can go ahead and execute that locally, and there's going to be a README file that's going to show you exactly how to go through and do that process. And I just brought that up on the screen right over here, so you can see that there is some syntax for this, whether we're doing this for a VMware environment or a KVM environment, a couple different flags that we can go through and set on this. It does use Python, so I want to make sure that those prerequisites are in place. And then you'll see some sample syntax for going through and running this, whether you're doing this on a Mac, Windows system, or Linux. And you'll basically be specifying the window of time for the analysis period so that we can actually find out and capture a good profile of the performance data. So all that historical application data, we want to make sure it's going to capture any kind of seasonal activity that may happen with workloads. Maybe we're doing a lot of data crunching just over a single point within a quarter. Want to make sure we capture that data when we go through and do the analysis here, so you can specify that window of time. Once you go through and complete the scripts and you run this locally, it's going to provide you with a tarred version of a JSON data, right? So what we'll do now is browse over to that file that we've already created, and we have this sitting right here on our desktop. So I'm going to go through and just click this button right here, and we'll use the import button. So we'll give this just a minute over here, and it's going to, first things first, go through and discover all the data. So it's found that I had 4 nodes in my VMware cluster. I have 252 virtual machines, and I had 6 data stores. I get a snapshot over here of the utilization of the on-premises environment. And as we let this run, you're going to see these fields on the left-hand side begin to populate as it begins to discover, my low utilization virtual machines, any kind of idle zombie instances, and it's already detected, our 5 terabytes of unattached disks. So let's just give this 1 second over here to complete. Okay, great. So you can see over here that it found 15 virtual machines that are low utilization and 227 idle VMs in our demo environment that we host here at HyperGrid headquarters. Now the next place we're going to go is under this VM usage tab, where we can actually look at all the instances it's gone through and discovered for me. So right now I'm looking at a list of all those instances, and you can see over here the performance data that it's collected, as well as the allocated amount of CPU and memory for each of these resources. Now this column over here in orange is going to show us the right size recommendation. So just looking at this first column over here, we have a 4 vCPU instance that was using about 15.25% of its CPU allocation. So we've gone through and we've provided a right size recommendation of 2 vCPUs. And then on the memory side of things, we had 10 gigabytes allocated, and we've gone through and given a recommendation of 3 gigs, where we're only using about 7% over here as actual real world utilization. Now the right hand side shows us the status of the instances and the uptime for it, and there's this little 3-button option we have on the right hand side where if we've gone through and we've actually done the discovery by connecting directly into vSphere, I can enforce the recommendations natively from the UI. In this case, where I went through and I imported the data from the JSON file, now I can go through and I can actually enforce those back in vCenter using the recommendations here and be able to export out this information. But when we connect this directly back over, I can enforce the recommendations. I can delete any of my zombie virtual machines, or more likely power them off gracefully and then wait and see if there are any kind of issues or any kind of need for me to maybe archive the instance before going through and deleting this, or do I want to be able to leave this instance online just running a low-level process on the system. Now the next thing we can look at over here is the disk's usage. So under disk's usage, I can find out which of those volumes are mapped over to which of my virtual machines. Now let's go to the migration analysis, where I can actually do that cost analysis and look at what this would cost to run on our public cloud provider. So we'll go ahead and press this Run Assessment button, where it's going to ask me which of my providers do I want to do the analysis for. So do I want to do this for AWS, Azure, GCP, or VMware Cloud on AWS? We'll start by looking at AWS, and let's begin our instance planning process. Next, it's asking me for the region. So which region do I want to do this for? And this allows me to go through and execute this, a number of different times to be able to compare costs across the regions. So I can find out, hey, is it going to make a lot more sense for me to deploy this in, a neighboring region versus one that's, much higher cost for each of those EC2 instances because, real estate and power costs are going to be more expensive in that area. So now I can go through and actually do a comparison of this and find out which one is a more economical option to go through and deploy my instances in. So again, let's just give this one moment to run. It's going to go through and do the cost analysis on those 240 or so virtual machines that it went through and discovered. Let's dig into the results from the migration analysis. And you can see right across the center of the screen, it's showing us again the total amount of virtual machines that we've discovered on premises, how many idle instances there are, how many are candidates for right sizing, and the total amount of storage. And just below this, now we can see the cost analysis. So again, this is reaching back into that data lake we're hosting with those 400 million different data points to be able to provide what the cost would be for these instances. Again, based on the instance recommendation and the sizes that we've recommended based on all that historical performance data. So the first row that you see here is showing us if we were just to run these as on-demand instances. So this will be our highest cost, looking at $118,000 to go through and do this. And then there's a monthly cost of $9,853. Nothing up front because we're using these as on-demand instances. But if we were to go to a 1-year term or 1-year reserved instance, we're looking at cutting that cost down by about 30%. So you can see that new value over here. And then there's going to be an upfront charge for doing the reserved instances and no monthly OpEx. Now, if we go even further and we look at going with a 3-year term, the annualized cost now is going to be less than half of what that on-demand rate is. So we get a really, really easy to understand comparison that's displayed for us right over here. And when we look over to the next column over, you can see the idle VM savings. So if we were to go through and address those idle instances that are most likely just zombie VMs that we have sitting in the environment, right off the bat, we're going to get about a 20% savings on that total cost. So really important to go through there and address all those, prior to doing any kind of migration. And the next one is looking over here at this right-hand column and seeing the right size savings that we have in the environment. So going through and implementing the right size recommendations is providing us with, over $40,000 in savings for that on-demand instance cost. So again, really important to be able to go through and put these things into place so that those charges, aren't just compounding year over year over year and really, really growing that public cloud bill. Now let's scroll down a little bit more and look at the details around, how we went through and sized the instances, because you can see on the left-hand side, these are all of the current resources, right, and the current resource costing. So assuming that we're not making any changes or implementing the right size recommendations, you can see what the size of the instances originally were. So this is how it's allocated on premises. And then we've mapped out for this what the target instance is out in the public cloud. So again, depending on the cloud provider that we work with, in this case, we're looking at AWS for AWS instance planning. But if I'm doing Azure or I'm doing GCP, we're going to get the provider appropriate instance size, target instance we have here. And again, this is all based on benchmarked performance, right? So we're doing our own benchmarking back in the cloud. We're mapping this back over to the workloads that we've identified on premises, and we're showing what that target instance size is, right? Now over here on the right-hand side, we're going beyond just the allocated resources, right? And we're looking at historical performance for the application. And you can see a couple of the cases here where we're recommending right sizing, where, this instance in production, if we were to move the workload to the public cloud, would be a C5 large instance. That's going to cost us $82 per month to run on demand. Now, if we were to implement the right sizing recommendation, it's going to suggest we use a T2 medium instance, and that's only going to be about $54 per month for us to run this. So again, we're looking at about nearly a 40% savings, just implementing the right sizing recommendations here. And again, we're giving a really easy way to digest what these costs are going to be, whether we're going with on demand, 1-year reserved instances or 3-year reserved instances, and being able to see that right sizing recommendation and impact that it makes on the bill. So I can export this report if I want to be able to save this and do comparisons across providers, be able to provide this back, kind of for internal purposes as we start to plan the migration, or information if you're providing this, as sort of a more of a consultative service to a client of yours. You can export out the report and be able to provide all the information and know that the recommendations that are being made have this data-driven backing behind them, and there's really an expert analysis that's taking place as we go through and do the migration assessment. So again, we can iterate on this and we can rerun the assessment for different cloud providers. If I want to be able to go through and do that, when I click this run button, I can go through and I can make all of our changes here, rerun this for Azure, rerun this for a different region to be able to do a comparison across these.